composition of two SHM having same period and same path but having a different amplitude and different phase. Now consider the first simple harmonic motion, that is x1 is equal to a1 sin omega t plus phi 1, and second x2 is equal to a1 sin omega t plus phi. The composition of these two means the addition of these two SHM, that is x is equal to x1 plus x2. Therefore, put values of x1 and x2, that is a1 sin omega t plus phi 1 plus a2 sin omega t plus phi. Now using sin a plus b concept, that is sin using the formula, that is sin a plus sin b, that is sin a into cos b plus cos a into sin. Here omega t means a, phi 1 means p. In this case omega t a and phi 2 is b. Using this concept, then x is equal to sin or a1 into bracket sin omega t into cos phi 1 plus cos omega t into sin phi 1, and a2 sin omega t cos phi 2 plus cos omega t into sin phi. Therefore x is equal to अपन a1 में मल्टीप्लाई करूँगा a1 sin omega t cos phi 1 plus a1 cos omega t sin phi 1 plus a2 sin omega t cos phi 2 plus a2 cos omega t sin phi. X is equal to the comparison केला पहिल्या टर्मचा आणि तिसऱ्या टर्मचा, तर sin omega t is common, therefore sin omega t into bracket a1 cos phi 1 plus a2 cos phi, and इस दूसरे टर्म आणि चौथा टर्म मध्ये वापर प्लस cos omega t into bracket a1 sin alpha 1 plus a2 sin phi. Now put r cos delta. This is very important putting. R cos delta is equal to a1 cos phi 1 plus a2 cos phi. So equation number 1. And r sin delta is equal to a1 sin alpha 1 plus a2 sin alpha 2. So equation second. This is very important equations. R cos delta is equal to a1 cos phi 1 plus a2 cos phi 2. Second substitution, that is r sin delta is equal to a1 sin alpha 1 plus a2 sin alpha 2. Now we get the x is equal to sin omega t into first bracket, that is r cos delta plus cos omega t into r sin delta. X is equal to r common sin omega t into cos delta plus cos omega t into sin delta. Therefore x is equal to r sin into bracket omega t plus delta. This equation, that is x is equal to r sin into bracket omega t plus delta, is called the resultant equation of two SHF, that is first x1, second x2. The x1, x2 and the a1 and a2 is the amplitude. A1 and a2 is the amplitude, different amplitude, but omega t is time interval or period is same. Hence the resultant equation of these two SHF is x is equal to r sin omega t plus delta. Now we calculate the resultant amplitude, the equation of resultant amplitude of these two SHF. Therefore squaring and adding equation 1 and equation 2. Squaring and adding of equation 1 and 2. This is the relation, that is r square cos square delta plus r square sin square delta, and which is equal to a1 cos alpha 1 plus a2 cos alpha 2 bracket square plus a1 sin alpha 1 plus a2 sin alpha 2 square. Therefore r square into bracket cos square delta plus sin square delta, which is equal to a plus b square, a आणि b चा वर्ग त्याचा विस्तारचा वापर करून a1 cos alpha 1 म्हणजे a, a2 cos alpha 2 म्हणजे b, a आणि b चा वर्ग चा विस्ताराचा विचार करू आपण. a1 square cos square alpha 1 plus 2a1 a2 cos alpha 1 cos alpha 2 plus a2 square sin square alpha 2. A square plus 2ab plus b square. Now second bracket plus a1 square sin square alpha 1 plus 2a1 a2 sin alpha 1 sin alpha 2 plus a2 square sin square alpha. Cos square delta for a sin square delta is 1, therefore r square is equal to, if we compare first term and this term, if we compare a1 square cos square alpha 1, a1 square sin square alpha 1, the cos square alpha 1 plus sin square alpha 1, that is 1 only. We can write in detail a1 square into bracket cos square alpha 1 plus sin square alpha 1 plus, if you compare this two term, 2a1 a2 cos alpha 1 cos alpha 2 plus sin alpha 1 into sin alpha 2 plus, if we compare remaining terms, that is a2 square sin square alpha 2, but there is cos square alpha 2 and a2 square cos square alpha 2, a2 square sin square alpha 2. Therefore, a2 square into bracket cos square alpha 2 plus sin square alpha. Therefore, r square is equal to, according to trigonometry, sin square theta plus cos square theta is equal to 1. Hence, this is equal to 1. Again, this term is equal to 1. Therefore, we can write r square is equal to a1 square plus a2 square plus 2a1 a2 cos phi 1 cos phi 2 into sin phi 1 into sin phi plus cos alpha 1 cos alpha 2 plus sin alpha 1 into sin alpha 2. Now squaring both sides, or before we can use the trigonometry here, that is the resultant amplitude r square is equal to a1 square plus a2 square plus 2a1 a2 cos phi 1 minus phi 2, or finally r is equal to under root a1 square plus a2 square plus 2a1 a2 cos into bracket phi 1 minus phi 2. This equation is called the resultant amplitude of 2 SHM, that is r is equal to under root a1 square plus a2 square plus 2a1 a2 cos phi 1 minus phi 2. And finally, we calculate the direction of these two simple harmonic motions, that is from equation 1 and 2 it is written as r sin delta divided by r cos delta, which is equal to a1 sin alpha 1 plus a2 sin phi 1 into phi 2 divided by a1 cos phi 1 plus a2 cos phi. R cancel, sin upon cos, tan delta is equal to a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi. Therefore, delta is equal to tan inverse a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi. Using this equation, that is delta is equal to tan inverse into bracket a1 sin alpha 1 plus a2 sin alpha 2 divided by a1 cos alpha 1 plus a2 cos alpha 2. Using this equation we calculate the direction of two SHR. Now we consider some cases. Case 1. If phi 1 minus phi 2 is equal to 0, that is this phase difference is equal to 0, therefore what is the resultant amplitude? a1 square plus a2 square plus 2a1 a2 cos 0. Put values of phi 1 minus phi 2 is equal to 0, therefore cos 0 is equal to 1, therefore r is equal to under root a1 square a2 square plus 2a1 a2, or this is nothing but r is equal to under root a1 plus a2 bracket square, or we get r is equal to a1 plus a2. If the phase difference is 0, then the resultant amplitude is r is equal to a1 plus. Now second case, if phi 1 minus phi 2 is equal to 90 degree, then the resultant amplitude will be a1 square a2 square plus 2a1 a2 cos 90 degree. Cos 90 is equal to 0, therefore r is equal to under root a1 square plus a2 square, because the second term is 0. And the third condition, or case third, that is phi 1 minus phi 2 is equal to 180, that is cos 180 is minus 1, therefore this into minus 1 or r is equal to under root a1 square a2 square minus 2a1 a2, or r is equal to under root a1 square a1 minus a2 bracket square, or finally resultant amplitude is A1 minus A. This is the three cases, that is cos for phase difference, that is phi 1 minus phi 2 is equal to 0, phi 1 minus phi 2 is equal to 90 degree, and phi 1 minus phi 2 is equal to 180 degree. Now we discuss the another cases, that is cases of equal amplitude. जर दोन एसएचएमचे एम्प्लिट्यूड सेम असेल, म्हणजे A1 A2 is equal to A, then this equation changes. The change of this equation is R is equal to under root A square plus A square plus 2A into A cos phi 1 minus phi 2. Therefore, R is equal to under root 2A square plus 2A square cos phi 1 minus phi 2, or R is equal to under root 4A square, not 4A square, 2A square साधारण into bracket 1 plus cos phi 1 minus. If the amplitude of two waves is same, then we get the resultant amplitude R is equal to under root 2A square into bracket 1 plus cos phi 1 minus 1. Again, there is same three cases. The first one is, first case is if phi 1 minus phi 2 is equal to 0, therefore R is equal to under root 2A square 1 plus cos phi 1 minus phi 2. If phi 1 minus phi 2 is 0, that means there is cos 0 is 1, therefore R is equal to under root 2A square 1 plus 1, that is 2. R is equal to under root 4A square, and we get R is equal to 2. This is the first case. Now second case, phi 1 minus phi 2 is equal to 90 degree, therefore R is equal to under root 2A square 1 plus cos 90 is 0. Therefore R is equal to under root 2A square, or R is equal to root 2 into A. This is second property or case. Now case number 3. If phi 1 minus phi 2 is equal to 180 degree, therefore R is equal to under root 2A square into bracket 1 plus cos 180. Cos 180 is minus 1, that is minus 1 plus 1 0, then whole term is 0, we get R is equal to 0. This is called the cases of equal amplitude. If amplitude of two SHM, ज्या दोन SHM आपण विचारात घेतल्या x1 आणि x2, जर त्यांची amplitude सारखी असेल तर resultant amplitude चे इक्वेशन चेंज होईल. ते होईल R is equal to under root 2A square into bracket 1 plus cos phi 1 minus phi 2, आणि जर phi 1 minus phi 2 0 असेल फेज डिफरन्स, तर R ची किंमत येईल 2A. जर 90 डिग्री असेल तर R ची किंमत येते अंडर रूट 2 into A, आणि जर त्यांचा फेज डिफरन्स 180 डिग्री असेल तर रिझल्टंट अँप्लिट्यूड हे 0 येईल.